Now starting, all attendees are in listen-only mode.
Hello everyone, this is Phil Vogels from JCO. We're going to get started. First I want to thank everyone for attending. We're very pleased to be launching JCO webinars. We had JCO seminars many years ago, and we're excited to bring that concept to the digital age. And certainly the level of excitement we saw for this particular webinar was very nice to see. I want to give a few JCO notes before we start. We are partially launching our new website tomorrow. So if you go there, you'll be able to see our brand new archive, which we believe is a massive improvement on our current site. You'll be able to see the articles there laid out for the web. They're done using responsive design, which means they'll resize themselves to fit your device. We'll have integrated images and video in with the articles and a bunch of other things. That new site is also where you will find our webinars in the future in the continuing education section. In the future, we also will be offering continuing education for the webinars. This one was free, and we are you're all sort of our guinea pigs, so we weren't charging for this. But in the future, we will be charging for the webinars, and purchasing either attending the webinar or the webinar recording will be done through the website. And the recording of this webinar will also be available on the website in the future. So before I bring Dr. Groth in, I wanted to note that we are going to try to keep tabs on questions as we go, since there's a lot of demonstration involved here, and if it's something that's a question about something happening right now, we want to try to get to it. So please use the questions feature on your panel if you want to ask a question. We obviously might not get to everyone, but we will do our best to keep a flow going while still answering questions. We are going to try to keep this to about 45 minutes. We will leave a few minutes at the end for some straight Q&A, general Q&A. And with that, I'm going to go ahead and turn this over to Dr. Groth.
Okay, can everybody hear me? Hopefully. Phil, you can hear me all right?
Yep, I can hear you just fine.
Okay, perfect. And Phil, you can see my screen with teeth on it. Is that true?
That is true.
Okay, good. I want to make sure we're on the correct screen. Thank you, Phil, and thanks for everyone who's tuned into this. I know it's probably all hours of the day and evening. We got people from all over the world here. I am outside of Detroit, Michigan, sitting in my 3D printing lab, Motor City LabWorks, and hopefully we get some good information out to you guys today. Any questions you have, please make sure you ask them. I'm going to be going over 3, maybe 4 different programs, and this is all demonstration today. So my whole goal in this is to get you guys information that you can take home immediately, and if you've got a 3D printer or want a 3D printer, you can implement some things that we're going to go over right away. The first program which I have open right now is Meshmixer. It's a free program by Autodesk. You can download it, and it is on all platforms, which is great because you don't have to have a Windows computer, since most CAD CAM programs are Windows based. This one is available on the Mac platform. The basic navigation of this program, they're all a little bit different. So for this program, the basic navigation, right-clicking the mouse is going to give you the ability to rotate the models, and clicking the scroll wheel, if you're using a Windows computer, clicking the scroll wheel is going to give you the ability to pan the models. So when you see me doing that, that's how I am rotating and looking at these. One thing I like to go over with people is just kind of the basic file structure when you're looking at a digital model. A digital model is created and made up of thousands, really tens and sometimes hundreds of thousands of triangles. And so I can turn on and off the wire mesh by pushing the W or going up to view wireframe here on the upper left-hand side. But this is basically how you're getting the structure of a model. Each point is a data point that is recorded, and you'll see more data points where there's more contour, just like a topographical map. As things flatten out, the data points go a little further away and the triangles get a little bit bigger. In addition to that, when models come out of scanners, they come out as what we call open shells most of the time. Now, if you're on the iTero platform, you can export these as closed shells or ABO models, but most of them come out, and the most common way of getting these is open shell, which is to say that there is a defined inside and outside of the model. When you have errors in the model, we call that inverted triangles, where the inside and the outside are flipped. This can very often give programs a lot of difficulty in processing. So eliminating those inverted triangles is something that's quite important. So let's jump in right now, and I'm going to go through basically the steps to prepare a model for printing. In Meshmixer, I'm also going to go over how to add teeth. If you have Ponic teeth you want to add to a retainer, how to remove brackets. If you're trying to do a pre-deband scan, you can do that in Meshmixer. And then we'll go over what an Invisalign file looks like, because we often at the lab get Invisalign files, and they're not the greatest files pre-Invisalign modification. So the first thing we need to do here is we need to make sure that the file is a good file. And the easiest way to do this in Meshmixer, you go down to the Analysis tab on the the left middle of the screen. You're going to be able to pull up the inspector. The inspector is basically going to highlight any hole that you have in this model. This model came off of a Trios 3, and so the Trios models are usually very, very good. And you can see that we don't have any holes except for the open shell. There are no holes interproximally or anywhere else that I need to repair. So that's a good thing, because that's one of the first things you want to do is repair any holes. The next step to get this ready is going to be to trim off any extra data that we're not going to want. And the easiest way to do that, if you click on the Select tab, and then simply, you have the ability to do this in two ways. You can either highlight by left-clicking, and you can change the size of that radius with the toolbar on the upper left, or you can simply left-click off the model and draw what you want to cut off. When you're printing models, you got to remember that every bit that you're printing is costing you more money. So the more data you can get rid of, so if you're just printing a horseshoe model for an S6 retainer, you want to get rid of as much data as you can and don't need. So when you look at this file, anything that's highlighted orange, I can delete by simply hitting the X key or using the clear selection button on the middle of the screen to the left. Oh, sorry about that. Hit the wrong button. So if you are using the trace function, you need to make sure to close this off, because if I simply go like this, it's going to continue that line. So instead of doing that, I'm going to clear this by hitting the escape button. I would need to close this off, make it a U, so everything to the right side of the screen and below the mark would be deleted. Obviously, I don't want to delete the molar, so we're going to get rid of that. So now that I've gotten rid of most of the extra data, I need to make this base flat, because printing, you want to make sure you have a flat base to put on the printer bed. So the first part of that is I need to extrude the base so that I can cut this off really nicely. In order to do that, I'm going to select the whole model. And so if I go into the Select tab, I'm going to use the Control-A key to turn the whole thing orange. Alternately, if you wanted to, you could paint the whole thing. It takes a lot more time, so Control-A, just like most Windows functions, will select the whole thing. Up in the Edit box, in order to get this Edit box available, you need to have a selection there. So I'm going to go to Extrude, which I can either hit the D button, which is the hotkey for Extrude, or I can go to Extrude. What this is going to do is this is going to give us the ability to pull the base away and just lengthen it out. And I'm doing it arbitrarily. I always pull it all the way to the right, just to make it a very large base that I can cut down however tall I want to. At this point in time, I don't change any other settings personally. I meant to say this at the beginning. I am a self-taught CAD CAM guy. I'm an orthodontist. I practice every day. I own and semi-operate a 3D printing lab, but there's no courses for this. So I may or may not be doing things in the most efficient manner, but this is what works for us. We print a couple thousand models a week, and so things work very well for us. I will say that we don't use these programs very often. I'm going to go into the program that we use most often in just a little bit. So once I have the extrusion where I want it, I hit accept, and you're going to see a couple things. You'll see that kind of gray tone. That's the model that I extruded out, and it's going to sit there and it's going to kind of live as a ghost model until I cut the base off. And in order to cut the base, apologize, get that off. I'm going to go to the Edit tab, and I'm going to go to Plane Cut. Plane Cut gives us the ability to draw a line. So I'm going to left click and draw the line where I want it. And then I get to pick where I want this to cut. I don't want to cut off the bottom, which is why the bottom is translucent. So I'm going to click this arrow on the right, which flips that to cutting off the top. You can see that kind of ghost model that I extruded that from. If I want to change how much is being cut off, I can drag this up and down. And again, you want to print as little as possible. So I like to have a couple millimeters above the highest gingival margin. We trim our retainers basically at the gum line. We scallop just about everything because they fit really nicely off a printed model, so we don't need anything extra. If you wanted to tilt this, you can easily use this curved area to the lower left, or you click the triangle, which allows you to pan this wherever you want it to be. So the cut type, I'm going to discard half. I'm going to use a remeshed fill. I'm just going to leave that exactly as is. I'm not going to change anything, and go ahead and cut it. So now we'll see that we've got that open shell still there because we haven't closed the model off, but we have a really nice flat base that we can build in order to print the model. The final step to get to printability is to make this solid. So over on the left-hand side, we're going to click the Make Solid button, and this is going to pull up another menu. One of the things that this program is going to do, and this is not a dental-specific program, this is a general CAD CAM program, so there's a lot of functions that we would never use as dentists and orthodontists. So you can see that it has pixelated this model because it has done this as a fast fill, but clearly we do not want to print and make an Essex retainer on a dumbed down model. So I changed the solid type to accurate, and then the solid accuracy and the mesh density go all the way to the right. In order to make this screen reflect this, we need to update the model. So this is going to go through a few calculations. Sometimes this takes a little bit of time. We're running pretty powerful computers here, so they usually are pretty quick. Give me just a second here, and we'll see what the result is. Normally, it looks very, very good. The next thing that we're going to go over is hollowing the model. Again, when you're printing, resin is money. So anytime you can reduce the amount of resin used, that's a good thing. So this is the updated solid shell. You can see a really nice flat base for printing, and the edge detail is back after we changed the solid accuracy and the mesh density. So I'm going to click accept because I like this model. And if you wanted to go and print, this is ready to go. However, I am not going to go print yet. Move the object browser out of the way. Because I want to save resin, so I'm going to take some of the resin out of the middle of this so that I can have this hollowed out. So right under Make Solid is going to go to Hollow. And we get to choose the wall thickness for this. In the lab, we print this at about 1.5 millimeters. But I'm going to show you the difference between a 1.5 millimeter and a 3 millimeter wall. What we're looking at right now is the gray portion is what's going to be removed. the translucent portion is what's going to remain. And so the more gray there is, the more savings you have when printing models. So I'm going to drag this up to about 3 millimeters, and I'm going to update the hollow. And you're going to see much less gray on this model, which means that we have very little hollow area inside. So you can see very little here is now gray compared to where it was. Because that's taking 3 millimeters from every point on this model, which is why it doesn't go down into the cuss tips at all. Now, if I drag that back down to about 1.5 millimeters, we're going to see a lot more gray in there. We have no issues with strength of the models, printing at 1.5 millimeters walls. So this is what I'm going to use right now, and I'm going to accept that. So if we were to go back and plane cut this just to see what it would look like, this is what our cross section is now. So we've got nice 1.5 millimeter thick walls with a hollow interior. And depending on the printer that you're using, there might need to be support structures inside that. We use object printers, so this is filled with a gel-like support resin, and it works very, very well for us. So this model will be ready to go. Once we're ready to go and print this model, we're going to go up to the file, and we're going to export this. We're not going to save this because that's going to save it as a Meshmixer file. We're going to export this, and it's going to save as an STL binary format, and we can name this whatever we want to name it, and it's ready to print. Any questions on that process from anyone at this point in time? I'll make sure that process was relatively clear. If you do, we're going to stay in Meshmixer here for just a little bit, so you can ask your questions. So I'm going to pull up another case here. Where are we? Wait 1 second. There we go. All right. So this is one of our patients, Grace. She was a maxillary advancement surgery, and unfortunately, upper left 4 had previous root canal treatment that failed and had to have that extracted. And she's in her mid-20s, did not want to walk around without a tooth. So we had to come up with a way to get a tooth in this X6 model. And my practice is impression-free. We've been impression-free for 3 years, almost 4 years. And so I was challenged with doing this digitally because I knew there was a way to do it digitally, but we needed to figure it out. So it's a very simple process. We're basically going to take 2 objects and we're going to merge them together. My practice is a large SureSmile practice, and one beautiful part of this is that Grace was already scanned into SureSmile. So I had a model of her teeth. So I'm going to click the import. Oops, I'm sorry. I'm going to click the import button on the upper left. And I want to append this model. I want to add to it. I don't want to replace it. And I already have tooth upper left 4 saved. I pulled that out of SureSmile. And so now I have a model and a tooth, and I need to go ahead and merge these. So the quickest way to do this is I need to get the tooth in the right position. So I'm clicked on the tooth model. If I push the T button, it pulls up the translate function, so I can rotate and move this tooth to wherever I want it to. It takes just a few seconds to get it into the basic position. And while I know that this is the exact tooth, so it's going to fit that space perfectly, I always make these a little bit smaller so that there's a little retention when you make that S6 retainer. So I'm just using the gyroscope in order to move it. And again, if I wanted to, I can move it around by hitting the triangle. I can rotate it by using the semicircle there. But if I want to scale this down, that's what these squares are for. So if I click the square, I'm going to scale that down in the direction of the square. So I make this just a little smaller than it ideally should be. Make sure it's pretty good in size of gingerly. Adjust the 3rd order here. And then once we think we're in pretty good position, we go and we're ready to merge these. In merging these, we have a couple ways of doing it. We can hit the control, select all. Sorry guys, clear selection, I keep hitting that button. But the best way is when you're in this object browser, which we see on the right, and if you don't see it, you can show it by going to the view menu, is control select both models. So now both of them are light gray, and a new menu pops up on the left side. And all I want to do is combine models. So now I have a single model, which you see on the right-hand side, with a tooth in it that we can make a retainer off of. And when the exact same thing happens, export, STL, rename for whatever you want it, and you're ready to print. Now there are models on the internet that you can get. It's relatively straightforward, and I don't know, Phil, if I can give JCO a file of models for upper and lower 7 to 7 if people want to be able to download that. It doesn't matter to me. Pretty easy to do. So we're going to get out of this and go into bracket removal. Don't want to save. Don't want to save. Oh, one other. Okay, so this is just a random scan we pulled up in the lab. I've already gone through the process of repairing this, planing it off, so we've got a nice flat base. But I want to remove these brackets because we're gonna make a thorough appliance to deliver when the brackets come off. So what we do is we're gonna go into the sculpting feature on the left-hand side, and the sculpting feature brings up basically this is like Photoshop for CAD CAM. We need to go to the brushes tab, and there's a lot of cool stuff we can do here, and we'll go over just a couple of them. But the main one we want, if we're trying to remove brackets, is the shrink and smooth. So what that's going to do is that is going to take whatever you are highlighting, and it's going to push it down to the average layer. And so that's going to be the average layer here is the labial surface of the tooth. I'm going to bring the size of the tool down a little bit. I'm going to bring the strength of the tool up a little bit. And so when I left click on this, you're just going to watch these brackets melt away. So I'm just going to do these for everything, and it melts away the excess glue around the bracket. And you'll get a little bit of a projection where the tie wings were, but in a thorough style retainer, that's not going to cause any kind of problems. So we'll go to this guy. I'll make a comment here. When removing brackets, the hardest thing to deal with is this. When you've got gingival tissue and bracket interfacing, the software and technicians are only as good as what they can see. So if you've got no tooth structure, gingival or apical to the bracket, it's pure guessing what that looks like. So if you're working with a lab and they're removing brackets and you're having fit issues, it very well could be due to excess gingival tissue and removing too much structure digitally. Therefore, you're creating a negative on that file and the retainer won't fit. It's one of the more frustrating things to deal with on the lab side and the clinical side when a retainer doesn't fit. So at this point in time, this is ready to go, and we can export this. If we wanted to label this model, which Meshmixer doesn't have a great way to label, but you can draw on there. So I can draw, and I can make this really very, very small. And let's say I just wanted to put my initials, draw C, draw G. So that would allow me to identify this when it comes off the printer. You can put it in an area where you're not going to affect the appliance fit at all. There are better ways to label, which we're going to get into in just a second. So that's the basics of Meshmixer. It's a very user-friendly program. There's a ton of stuff in it that I don't know, I don't care to know. I use it regularly to add Pontics to teeth, but when we need to repair files, it's a very nice program. So I'm going to switch programs here. If there are any questions, please let me know. All right, so we're going to go into 3D Builder, which is another free program from Microsoft. It comes free on any Windows 10 build. And I've already loaded the model up, and this is the first screen that you see in 3D Builder. The program wants to know, it's asking us what the units are, and this is a millimeter unit model, so we don't need to do any changes to this other than say import model, and now we have this model in the program. The navigation in 3D Builder is a little bit different in the sense that panning is the right click button and rotating is the left click button. Now, if we wanted to reorient the model, the checkerboard base that you see here represents the print bed, and so this model would print perpendicular to the occlusal plane and perpendicular to the print bed, so which is inefficient. I don't want to do that, and so I'm going to change the orientation. The menu on the bottom is really how we want to move the model. So since I want to rotate, I'm going to go to the Rotate tab. I never want to go to the Scale tab because that's going to change the size of the model. So if you scale this model up or down, the appliance that you're making is not going to fit. So I don't ever use that. I don't ever click it. I don't want to click it. And I'm going to rotate this 90 degrees so that that model is now resting on that print bed base down. So a couple things. We still have an open shell, as you can see. Shell's not closed. In order to close that off, we have a couple ways of doing it. The easiest way is just to click that bottom right, which is going to go into an auto repair function. This can take anywhere from 10 seconds to 3 or 4 minutes if you've got a file that is not quite of great quality. So I'm going to let this work for a little bit. The next step is going to be the same step that we did in Meshmixer, with the exception of the select and remove. This 3D Builder does not have a great select and remove tool like Meshmixer does. The next step, we're simply going to go into the extrude step, which is under the edit menu. You will notice that 3D Builder has much fewer options as far as things to do with it, because this is a program that was designed for consumers to use to print, not for CAD CAM professionals to use. So now you can see that that model has been closed off. So it's no longer an open shell. And if you wanted to go and print right now, you can. This is absolutely a printable model, but it doesn't have a flat base. And so I want to extrude this base down. What the extrude down function does is it basically is taking, and I'm going to actually cancel this just a little bit. I'm going to adjust the tip on this guy. It's going to take everything below the selected plane and extrude it down. So if I were to extrude down from here, I'm going to lose all the data gingival to this plane. So I want to make sure this plane is below all the important structures. And you can see I'm right at the gingival margin of the canine, and I'm actually in that second molar, so I'm going to bring it down even a little bit more. And that'll work for what we're doing right now. So once I have that in a place I like it, I'm going to hit extrude down. And this takes a minute to do. Basically, this is just extending that model down to the print bed, making it taller than we need it to be, which then allows us to go back and cut that model with a nice flat base at the point that we want it cut. Okay, model done. You can see it took the plane and just pushed it straight down to the print bed, which is why you see all these vertical striations. And because you can see on the inside, because we didn't have anything in there, it actually didn't extrude down. Not a big deal. We can still create a flat model for good printing. So now I'm going to go up to the split function. Same exact idea. We have this plane that we're going to drag up to where we want it. I'm just going to put it right there. I can keep the top, I can keep the bottom, or I can keep both. Clearly I want to keep the top, and so I'm going to hit split. And now I've got a model with a nice flat surface. You can see that there are some areas on the base that aren't perfectly flat, but again, that's not going to create an issue for the printer. This allows me to have a nice flat spot to put it on the bed. So 3D Builder is really the best way to label models. And so there are 2 ways to label models. Same function, but 2 different directions. We're going to use the emboss step. So the emboss step allows us to pick whatever we want as far as the text, and we can either emboss it into the model or we can extrude it out of the model. So I'm just going to put my name in here, Groth, and we're going to do this one as a base embossing. And in order to adjust the size and position of this, we're going to go down to our tools at the bottom. So if I wanted to change position, I'm going to use the far left move button. Put it wherever I want to put it. If I wanted to change the rotation on this, I'll use the rotation tool. And then if I want to change the scale, so make it bigger or smaller, I'll go to the far right. So this is the only time I hit that scale button is when I'm using the extrude emboss feature. Now, what we don't want to have happen is we do not want to have this text being extruded out of the base. And so we need to emboss it into the base. The way to do that is this blue arrow. We grab the blue arrow and we push it up. Now you can see it's gone from outside to inside, and you can drag that up as far as you want. It really doesn't make much of a difference. You just want to have it in there enough that it is not sticking out. Once you're happy with the position, we can go ahead and hit the emboss. And this is usually pretty darn quick. So what this did is this just popped up an error. One or more objects invalidly defined. I'm not going to click that to take up time, but you would click that in order to repair whatever happened. Usually that's an error in the mesh around the emboss, and so it can easily repair it. I'm going to leave that red box there because we're only going to be in this for just another minute. So the other way to emboss here is let's say that I have a series of clear aligners, and I want to put a number onto the model so that it shows up in the thermoform. The way to do that is we're going to call this number 1, is to put it on the molar, but we're going to reverse this from an emboss to an extrude. And so this is going to be a positive on the model, which is going to show up on your thermoform appliance. And if you wanted to flip it upside down because you want to view it with the occlusal surface, that's fine. You can do whatever you want to do. Once you're happy, hit emboss, and now you've got a molar with a number 1 on it, and you can label every single model if you wanted to go through and do that. It's a convenient way to do it. It takes a lot of time though, so we don't do any of that for any of the minor tooth movement we do in the lab. I do know people that do this, and so I wanted to show it. And this can be done for anything. You can put initials in there. You could, whatever you want to do that would show up in the retainer when it's formed down. All right, any questions on 3D Builder? If not, I'm going to jump on. We're going to do about 10 more minutes and then some question and answer. I'm going to bring in our preferred program, which is OrthoAnalyzer, which is a 3Shape program. This is not a free program. This is a paid program. You do not have to have a Trios scanner in order to have OrthoAnalyzer or any of the 3Shape softwares. So I'm going to run through the preparation steps. This is the exact same model that we used before to remove the brackets. And I'm going to just show you guys how quick and easy it is in this software to get something ready for printing and remove brackets. First step is to orient the software because not all the scans are coming out of 3Shape scanners. So I'm picking the palatal plane, which is basically oriented with the molars and a point on the incisors. Then I'm going to pick the sagittal plane. This is telling the software where everything needs to be. There we go. There's my menu. Okay, now I am going to tell the software the data I want to keep and the data I want to throw away. So I'm just going to trace across this. And this line, inside the line, software is going to keep it. Outside the line, the software is going to throw it away. Then I go to add my virtual base. So I'm going to make this base 25 millimeters tall. And I can move this base however I want, making sure that all of those splines. That line with all the blue dots is called a spline. Make sure all those splines are inside that base. So everything looks really nice there. So now I've got a closed model. This is ready for printing if you want it to go. However, a lot of extra plastic on here, so I need to get rid of that in order to make sure that we're printing efficiently. So once we're in the sculpt menu, I'm going to use the spline cutting tool to really go back and do what we just did, which is definitely a workflow issue that the software has, but it doesn't take much time, and I'm going to be a little sloppy with this just so we can get through it. Cut around the model, and depending on the direction you go, the software is either going to throw away the inside or the outside. Like here, we don't obviously want to throw away the inside, so all I have to do is click the reverse direction button on the left-hand side. And it's going to go through its calculations to reverse what it just did. Software should be smart enough to save everything, but obviously a glitch. So once I'm happy with the cut, I can go and move these if I wanted to. I hit the play button on the left, and you can see I've got a nice flat base. I've got a palette in there, and I just need to remove brackets. So the bracket removal is done with this Remove Artifacts tool. All I'm going to do, bring this size down a little bit, is trace around the bracket. And I'm telling the software that this thing isn't supposed to be there. So it is going to look to the area around it, and it's going to automatically fill it in. So bracket's gone. Let's go to the posterior. This is where things get sometimes a little uglier. So you can see we've got a little bit of a divot in there. If I reverse that. Do that one more time. But you can obviously see this is significantly faster than Meshmixer. Then the last thing I always do is I go to the wax knife tool and I smooth out all of these just to make sure that there's no little bits of extra glue that popped up there. I can go here smooth. If I wanted to add a little structure back because I was worried that we took away too much, I can add some back. Same thing over here, smooth things out, make sure things look really nice. And then we're done. Model is ready to print. Labeling, in our lab, labeling is done with a third-party software that bulk labels the models. If you wanted to label this model, you could bring this into Model 3D Builder and label it. So I wanted to show the difference between the two models here. I've got both in Meshmixer, the Meshmixer repaired file on the top, the OrthoAnalyzer repaired file on the bottom. So you can see how it's just a much cleaner repair. Clinically, it doesn't make much of a difference, but it is something that to take into account. Last thing I want to show is within OrthoAnalyzer is, oh, it's on my other screen, right over here. We have the ability to perform all sorts of measurements. If we wanted to measure caliper, 3D measure, we can do that. But the most interesting thing for most people is the ability for us to segment the teeth for virtual setups. So I'm going to go real quick through this because I just want to show it. We don't have a ton more time. I'm basically telling the program the mesial and distal points, and I'm looking down the tooth through the long axis to tell the software what the long axis of the tooth is. It's going to think that's a canine, but that's okay for now. So once I've picked the mesial distal points, the software is going to automatically find the gingival margins. On the teeth that we've removed the bracket, sometimes the margins aren't quite as accurate. You can see that's actually pretty good. I can change these as necessary. We can see here, obviously that's not correct. I can draw that margin in. So I can repair it so it's where it's supposed to be. Then I'm telling the software to separate tooth from gum tissue, and which is what's going through right now. separating everything off so that we have a model that we can make staged movements on. To do that, we go into the virtual setup tab at the top, and I can do anything I want to do. If I can use this for treatment simulations, I can use this for model stage movements. I'm just going to play around with this and move some teeth just to give you guys an idea of what we can and can't do. Gingival tissue moves to the best of its ability. We have a table on the right-hand side that allows us to see the movements that was done in all dimensions. The best part about this for me is I have the ability to measure points, and that allows me to dictate how many aligners this needs to be done. So I picked mesial and distal points on the teeth that I moved, and you can see if I zoom in enough, 1.85 millimeters, 1.71 millimeters. So those are going to be the rate limiters. If I believe that teeth can be moved at 1/4 millimeter per tray at 1.85 millimeters, that's approximately 8 trays. So in order to do that, I go to the subdivide setup, hit 8, and I now have a staged aligner sequence, which I can play through the movements here, which I can individually export and print these to make thermoformed appliances on. This is one of the biggest upsides of OrthoAnalyzer to me. It's a great program. It serves as a database, and there's a lot of things you can do with it. Obviously, the ability to quickly prepare a model for printing is the #1 thing for me. In about 3 minutes, I can go from a raw file to a printable file, and whereas I don't have that ability in the other programs. The last one I'm going to show really quickly is NetFab, which is another paid program, which we have the ability to all-in-one repair. The only thing I need to do is extrude, which I'm not even going to show that. I can patch holes, decimate the file so there's not as many triangles, close off the base, and get it ready for plane cutting in one fell swoop with NetFab. This is another program that's meant for CAD CAM engineers. Since it's a paid program and it basically has the same functionality as Meshmixer or 3D Builder, it's not something that most people are interested in. But I did want to show the interface. And it does allow you to batch actions together. And so right now it's going through all of our custom repair actions, which usually take a couple minutes to do. I am trying to think if there's anything else here. Oh yes, the Invisalign file, last one. So Invisalign files are not great files. This looks like a pretty good file on the surface. Not a lot of gingival tissue, but that's okay. It's, it would work. However, what happens when I go into the analysis and the inspector, that's when all of the holes in this file become apparent. So every single point on here is a hole in that file. And I can go through and click on these to repair the holes. Most of them are interproximal, which is not usually a major issue. However, the more holes that are generated, the tougher it is for the program to figure out how they need to be repaired. So if you're exporting Invisalign files that are pure Invisalign files, it's not the easiest thing to do to get ready for printing. They should be iRecord files. So scanning on iRecord and Invisalign is the way to go. So looks like we're just about at Q&A time. So if there's anyone that's got questions and that want to be answered, I will do the best that I possibly can. You there, Phil, still?
Yes, I'm here.
Okay, good. So I make sure you're still there. Looks like okay, yeah. So question, by Invisalign file, I mean an iTero file. Yes, yes and no. When you scan for Invisalign, you can export the iTero file from the MyAlignTech site, and you can export that file, but when you're on the iTero, you can select an Invisalign scan or you can select an iRecord scan. The iRecord scan does the patching and repairing of that file automatically without you having to do it, whereas the Invisalign scan, it doesn't repair anything. And there are some circumstances where the holes are so big and Invisalign takes the liberty and patches those holes with their software, which has the ability to do that, but our software that we have doesn't have that ability. So we're purely guessing what this tooth structure looks like if the repair can actually even happen. So yes, these are iTero files, but there are two different scan modes when you're scanning with the iTero, the Invisalign scan and the iRecord scan. Hopefully that answered the question. Anything else from anybody? Looks like we wowed everybody, Phil. No questions because we did so good.
Yeah. So, and obviously, if anyone has a question that's a little more general, we can answer that as well. If not, I do see one there. I just want to say one thing. You do have an article, I believe, coming up with Dr. Kravitz in JCO on this topic.
Yep. Yeah. So this is in the JCO. Obviously, one of the reasons I wanted to do this webinar was you can only do so much in a written article. This subject is much easier to do live and show how the workflows work. So another question is which 3D printer do we use? You guys may have heard the Printer Complete in the background. We're using in the Stratasys Eden printers. We got a pair of those in our lab right now. We will also likely be bringing on EnvisionTech printer in the near future. Workhorse printers, when we're printing a couple thousand models a week, we need printers that are very, very reliable. From a standpoint of bringing a printer into a practice, really the most economical one to start out with is the Form 2. It's a great printer. It's slow just because it's a stereolithography printer, but you can't beat $4,000 for a printer that has really very good accuracy. When you start doing more and more models and more printing, you either need to bring multiple form printers online or you'll upgrade to a little faster printer that has a higher capacity. And then Michelle, looks like there was a question, will the Meshmixer tutorial be available? Yes, the whole webinar is going to be available. So if you missed the Meshmixer portion of that, it will be archived and Phil will have the ability to get that up.
Yeah, and that will be through our website. It is through the new website, so it's not going to be available right away. But we will be uploading this also to YouTube. So I think there'll be a way to get it through there, but if not, it'll definitely be available through our website in the future, and we will contact everyone to let them know via email, the email you use to sign up for this when it is available.
Right. So Gary just asked, can models prepared with OrthoAnalyzer be hollowed prior to printing? That's not an automatic workflow within OrthoAnalyzer. It is something that 3Shape has asked us because we've got a unique practice and printing business here, so we understand both sides of the equation. They asked us some things. It's something that they are looking to roll out where there's an automatic hollowing function. So it doesn't happen automatically. It's part of the Cambridge suite that we use, which is a 3Shape product that labels and hollows automatically. So models would need to go into another program, either 3D Builder or Meshmixer to hollow if you wanted to hollow this out. If anybody has questions beyond this, welcome to email me. It's my last name, Groth @T as in Tom, D as in David, R as in Robert, ortho.com, tdrortho.com. I'll do everything I can to help people. This is a new portion of our field. We're all learning, and I learn new things every day from people who are doing this stuff. So I'm willing to do anything that I can to help people out.
All right, great, thanks. I think if there aren't any other questions, we will stop it there. So thank you everyone for coming out, And obviously, thank you, Dr. Groth, for the presentation.
Yeah, Phil, thank you, and thank you for everyone who spent the last 45 minutes with us. Always fun doing this stuff and talking to a computer screen. It's always fun. Name of the 3D printer. Yes, so we are on a Stratasys Objet. So Stratasys is based out of Minnesota in the United States. The printers are built in Israel, and the Eden line is the printer that we use. They have several lines. Eden is the kind of the first of the industrial line. They also have the Orthodesk, which is more of a desktop printer. Same technology, just a little bit smaller and fewer print heads, so it's just a touch slower. But that's Stratasys, Stratasys.
All right, thank you, everyone.
Thank you.